In this video, we're going to look at factoring higher order polynomials like the two on the board that have an exponent to the fourth. Now, let's look at the one on the left to begin with. What do we notice about each of these terms? Well, they all have a 2x squared in common. So let's take that 2x squared out. What are we left with? Well, in this case, we're just at x squared. We got to keep the negative sign, so minus 4x and minus 5. Now, from here, it's up to you whether you want to do the AC method, the box method, or the guess and check method. I don't want to go into detail about that, but I'm just going to bring this down, and then I'm going to use the guess and check method because that's the method I like. So we know x times x is x squared. Now, what can I get from this negative 5 and this negative 4 here? Well, I know that this is negative, so one of my pieces has to be negative. And what are the pieces of 5 that will give us 4? Well, we know that if we do 1 and 5, will that work? Well, that x times x is x squared. Inside is 1x, outside is negative 5, so that gives negative 4x, and then 1 times negative 5 is 5. So we're good. We've factored this piece, and if we wanted to, we could find the zeros by setting each piece equal to 0. Now, let's look at this piece on the right. What is a common factor? A common factor in this case is 3x squared. So we're going to factor that out, and we get x squared minus 8x plus 4. Now, you can't do the AC method, the box method, or the guess and check method in this way, in this case, because it's not factorable that way. So we're only left with one other option, the quadratic formula. It's everybody's favorite, I know. So in this case, when we factor this, we got to use the quadratic formula, which is negative b plus or minus the square root of b squared, well, that's 64, minus 4 times a is 1, times c is 4, all over 2a. Well, a is 1, so we just have 2. Now, when we distribute the negative here, we just get 8. And 4 times 4 is 16. 64 minus 16 is 48. And you can check me on that. All over 2. Now, what we need to do is divide this 48 into its components. We know that we can do that if there's a perfect square. So is there a perfect square in 48? Well, it turns out that there is, and it's 16 times 3. Okay, and then now we can take the square root of 16 times the square root of 3. It's the same thing. And so we have 8 plus or minus 4 square roots of 3 all over 2. And then we can divide each piece by 2, and we get 4 plus or minus 2 square roots of 3. Now, those are the zeros, so how does that help us with this piece of the equation? Well, we're going to rewrite that piece like this. X minus the positive piece first, 4 plus 2 square roots of 3, and then times x plus 4 square roots of 3. 4 minus 2 square roots of 3.